Alright, today we're going to solve radical equations and inequalities. You guys have been working with radicals for the past few days. Today we're going to add some variables and solve for x. Today we're going to do radical equations, tomorrow radical inequalities. A radical equation contains a variable within a radical. Recall that you can solve quadratic equations by taking the square root of both sides. Similarly, radical equations can be solved by raising both sides to a power. So when we had, sorry about that, x squared equals, 4, we would solve both sides by taking the square root. Now we're going to have the square root of x equals, 6, and we're going to raise both sides to a power. Cool? Alright, our steps. We need to isolate the radical. Get whatever is in the roots, either the square root, cubed root, fourth root, whatever, on one side of the equal sign and everything else on the other. Then you want to raise both sides of the equation to the power equal to the index. There's the index, raise it to the same number on both sides and solve. Remember, for a square root, the index of the radical is 2, but we never write that 2 in there. Okay, our first step was to isolate the radical. So I have the square root of x plus 1 equals 11. It's a square root, so I want to square both sides, and I have x plus 1 equals 121 minus 1, x equals 120. Okay, let's try another one. We need to isolate the radical. I need to get rid of that 7. The 7 is currently multiplying, so I'm going to divide. So I have the cubed root, 5x minus 7 equals 12. It's a cube root, so I want to raise both sides to the third power. I get 5x minus 7 equals 12 to the third power. 1,728. Add 7. And divide by 5. Okay. You try it in your own. Push pause, please. Okay, there's the first one. Check it out. Try another one on your own. There's the answer to the next. Check it out. X equals 4. The last one. Okay, isolate the radical. Do it on your own. There you go. Last one. Let's try our next example. Now we're going to solve equations containing two radicals. So in these examples, you want to make sure that you have as much of a full radical on one side of the equal sign and a full radical on the other side of the equal sign. And we're just going to square both sides. So when I square the left side, I'm left with 7x plus 2. On the right side, 3 squared is 9, and then 3x minus 2. We're going to simplify. 9 times 3 is 27 minus 18. Get all the variables on the one side. Plus 18. Solve for x. X equals 1. Okay, your example, push pause, same type of problem. There's your second example. Let's try one more on your own. Okay, push pause and try on your own. This is a cubed root, so you need to raise it to the third power. And there's your check it out example 2b. Moving on. Alright, we're going to move on to the third example. Each one of these problems you can work with your calculator or you can work with algebra. I'm going to give you the calculator page that the book provides, and you can go ahead and try it using the intersection function. It's obviously very difficult for me to model the calculator doing a video, so if you'd like to try to work the problems that way, we can do some little one-on-one work the next day. So our first example, solving equations with extraneous solutions. Remember, this means extra solutions, solutions that don't really work. So we have square root of negative 3x plus 33 equals 5 minus x. You can use your graphing calculator and put the left hand of the equation into L1, the right hand of the equation into L2, or I'm sorry, Y1 and Y2, and graph it and check the intersection. The intersection is one of the seconds underneath the window. I don't have my graphing calculator with me, but we can find it tomorrow. But let's go ahead and try this algebraically too. We're going to go ahead and square both sides. That means on the left I have negative 3x plus 33, and on the right I actually have 5 minus x. 5 minus x. That gives me 25 minus 10x plus x squared. Solve for x. I'm going to move everything over. So I have 0 equals negative 8 minus 10x, 7x plus x squared. That doesn't work for me, so I need to go ahead and flip it. I have x squared minus 7x minus 8. I can factor that into x minus 8, x plus 1, which gives me x equals 8, x equals negative 1. Okay? Now we have to check these answers, so I'm going to move to the next page. I have to check all these answers to make sure that they work. So we go back to the original equation, negative 3x plus 33 equals 5 minus x. Now we had x equals 8. That's an awful 8. And x equals negative 1. So square root negative 3 times 8 plus 33 equals 5 minus 8. Okay, pulling out my handy dandy calculator. Plus 33. I have 3 on this side, negative 3 on that side, so that does not work. Chances are the other one's going to, but let's go ahead and check it. Negative 3 times 1 plus 33 equals 5 minus a negative 1. Okay, I have negative 3 plus 33 is the square root of, sorry, this is a negative 1. Positive 3 plus 33 is 6, equals 6. So x equals 1 is the only answer. X equals 8 does not work. Alright, you try this one. Again, you can put this into y1, this into y2. Where they intersect is your answer. Or we're going to do some algebra. Square both sides. I have 2x plus 14 equals x squared plus 6x plus 9. I just did x plus 3, x plus 3. Move everything around. Minus 2x, minus 14. I have x squared plus 4x minus 5 equals 0. I'm going to factor this left-hand side. I get x plus 5, x minus 1. So x equals -5 or x equals 1. Let's test them. My problem was the square root of 2x plus 14 equals x plus 3. I'm going to test x equals -5 and x equals 1. So here we have 2 times -5 plus 14 equals -5 plus 3. On the left, using my handy calculator, square root of 4, yikes, equals 5. -5 plus 3 is -2. 2 equals -2, not possible. Let's try the other one. Square root 2 times 1 plus 14 equals 1 plus 3. So 14, 15, 16, 17. Square root of 16 equals 4. 4 equals 4. That works. That does not. Okay, last example. So you can check in your calculator, or I'm going to let you guys do this next one all on your own. So, algebra. Push pause and get your answer. Okay, there's our answer. I'm going to turn the page and check them. Alright, our example was square root 2x. Hold on, I'm still having the wrong example. Let's erase that. That was the square root -9x plus 28 equals -x plus 4. Square both, I'm sorry. We're going to check x equals -4 and x equals 3. Go ahead and push pause and do this one on your own. In this example, they both work. That's all we have for today. We'll finish up the lesson tomorrow. Good job.